Hello everyone, I am Nishit and today we are discussing about tree and graph data structure.
In this video, we are covering these major topics like introduction of tree and graph data structures, understanding tree structure, understanding the graph structure, tree versus graph, the difference between tree and graph. We are going to discuss application of graph in computer graphics, application of tree in computer graphics, importance of tree and graph structure, tree traversal techniques like in order, pre-order, post-order, depth first, breadth first, graph algorithm like depth first search, shortest path algorithm, types of tree structure is computer graphics like binary tree, quad tree, and octree, challenges and limitations of tree and graph data structures, conclusion, and the future development that requires in tree and graph data structure for making it more efficient and good to use. So what is tree and graph data structure? Tree and graph data structure are essential in computer science and data representation. Without them, it is difficult to represent data in a hierarchical or in a network form. Tree and graph structures are fundamental techniques for representing data in various fields, including computer science, mathematics, visualization, ta- uh, computer graphics, computer networks in this field, which we require tree and graph data structure.
So, what is tree structure? It is used to represent the structure of 3D model. It is collection of vertices, node and edges. It is a non-linear data structure and its root node is the starting point and it show hierarchical relationship that is parent and child relationship.
So this is the example of tree data structure. The tree data structure is look like this. The A is root node, key, or a vertex. It is the main. This is his children's, and this children is also called parent because it has two children's, and these two children's are also called siblings because D and E are siblings, and similarly C is parent and G and C are his children's, and they both are G and C has a relationship of siblings uh, and similarly to K, L, M, and O, P are the leaf nodes because they are in the bottom of the tree structure. And it has also levels. In this tree example, we have four levels like 0, 1, 2, 3, 4. This is the four level, and this is the height. The height of this tree is 5 because 1, 2, 3, 4, 5. The height of this is 5. What is graph data structure? A graph is a non-linear data structure consists of vertices and edges. The vertices are something also refers to as a node, and the edges are lines or arcs that connects two nodes in the graph. The graph is composed of set of vertices V and the set of edges E. The graph is denoted by G, E, V, comma E. So this is the example of graph data structure. This is a graph data structure. This directed graph because it has arrow in it between this is edges, directed edges, and this is vertices. It has no root node, like graph, like tree data structure. And it has also a self loop, like this. D has a self loop, D has a self loop. This is disjoint because it is not connected to the graph and it is represented by a matrix. This is a matrix. Uh, and the difference between tree and graph data structure. Tree, a data structure that simulates a hierarchical tree structure with a root value and subtree of children with a parent node is called a tree data structure. A data structure that consists of a group of vertices containing through edges, like two vertices are connected to an edges, is called a graph data structure. There is a root node in tree data structure. There is no root node, no such root node is present in the graph data structure. There is no loop in tree data structure. It is like a hierarchical structure. There can be no loops. There can be loops in graph data structure. It can be cyclic. It has loops. Represents data in the form of tree structure in a hierarchical manner. Represent data similar to a network. Tree is less complex. Graph is more complex. Two major types are binary tree and binary search tree. These two are majorly used in tree data structure. And two major types of graph are directed and undirected graph. In directed, the direction is given like from A to B. And in indirected, it is not clear that the node is the edges is from A to B or B to A.
Now, application of graph in computer graphics. The first is routing algorithm. It's find shortest path, optimize traffic flow, like example GPS and navigation system. Second is network visualization. Represent connections between nodes, identify clusters and communities. For example, social network analysis. And the third is scan graph in 3D graphics. It represent of 3D scans, hierarchy of object transformation and relationships. Example, modeling a virtual environment is come under the graph data structure. Now, application of tree in computer graphics. First is decision tree in classification. In this, we make decisions like this or that, or yes or no kind of tree classification and classification of data like categories and these types of data comes under the decision tree. And the second is modeling relationship in data using tree. In this organizing tree hierarchical data and parent-child relationship like organization structure. The third is animation hierarchies in motion graphics like skeleton rigs of characters animations, hierarchical relationship between joints and bones, for example, character movements and deformations.
Importance of tree and graph structure. First, efficient data representation. Tree and graph structure are often efficient way to represent complex visual data in computer graphics, enabling faster rendering and processing. Second is hierarchical organization. These structures provide a hierarchical organization, facilitating easy manipulation and traversal of complex scenes and objects in graphics. Third is optimized spatial partitioning. Tree and graph structures play a crucial role in optimized spatial partitioning of sciences, enhancing the rendering processes in computer graphic application. So these three are the most important importance of tree and graph structure in computer graphics. So these are some tree traversal technique. The first is pre-order. In pre-order, we first go to the root node and then left side of the tree and then right side of the tree. Uh, in order, we first go to the left side of the tree, then root node, and then right side of the tree. And after that, the post order, we go for left side of the tree and then right side of the tree and then root node of the tree. Depth first search, depth first and breadth first traversal. Depth first traversal. Explore as far as possible along a branch before moving to the next sibling. In this, we go to the last node of the tree and cover all the between nodes. In breadth first traversal, visit all nodes at a given level before moving to the next level. In this, we go to the first level and then cover all the nodes, and after go to the second level and then cover all the nodes, and after that go to the third and go to the last level of the tree. Example: navigating through a directory structure. So these are some graph algorithm. First is depth first search. In depth first search, it is a traversal algorithm. In this, we go from root node to the last node of our graph, covering all the nodes between them. Like we go from A, then B, then E. The next is depth first search. Uh, in breadth first search, we cover all the nodes in the same level and then go to the next level, like A, then B, C, D, then E, and then F. The other algorithm is shortest path algorithm in Digitras and Bill. As the name suggests, shortest path. In this, we find the shortest path from point A to B, and that covers minimum number of nodes or vertices. The real life example of shortest path or finding shortest path is finding shortest uh, routes in a network.
Types of tree structure in computer graphics. First is binary tree. It is a hierarchical data structure with two children per node, used for space partitioning and collision detection. Second is quad tree, hierarchical data structure with four children per node, ideal for 2D spatial data indexing and comparisons. Then the third is octree, spatial partitioning tree with eight children per node, uh, commonly used in 3D graphics for spatial indexing and collision detection.
So these are some binary tree types. The first is full binary tree. The condition of full binary tree is the parent should have two or one or zero number of children. In complete, the parent can have one children. In degenerated, the parent can have one children. Uh, it is look like a zigzag line. In perfect, the children are in the same level. And then balance tree, the it should balance the tree. Quad tree and their application in computer graphics. First application of quad tree is image processing in computer graphics. Quad trees are used for image compression and efficient storage of image. They divide image into four quadrants, allowing allowing for quick retrieval and manipulation of image data. The second application is collision detection. Quad tree are utilized in collision detection algorithms in computer graphics, enables efficient in identifying of objects intersection. And the third is space partitioning. Quad trees provides a means of dividing 2D space into regions, facilitating spatial indexing and efficient search optimizations in computer graphic application. This is the example of quad tree, and this is the diagram, and this is the 2D figure. So in one node have four children, as we have studied in quad tree. Each node have four children, and 8x 8 by 8 first node, then second is 4 cross 4, then 2 cross 2, and then 1 cross. And these are all single, and this children is one pixel of this 2D graph. Octree and their application in computer graphics. The first application of Quadtree in computer graphics is 3D modeling. Octree are used for efficient storage and retrieval of 3D model data. The second application is rendering optimization. Octree aid in optimizing rendering performance by spatial organizing scan data. And the third and the final application of Octree in computer graphics is collision detection. Octree enables fast and accurate collision detection. It is accurate and it enables fast and accurate collision detection in complex 3D environment, like 3D environment like gaming environment or any image environment that is 3D, which is 3D environment. It enables fast and accurate collision detection in the 3D environment. So this is the example of Octree. It is a 3D cube, and this is the one node. One node have eight children. It is compulsory for having an octree, and this is a 3D cube, and this is also the part of 3D cube, and it is divided into 4, so total it's 8. Challenges and limitation of tree and graph data structure. Handling complexity and computational intensity in optimization problems. High storage requirements and algorithmic complexity for large scale operation. This comes under the graph data structure. This is the challenges and limitation of graph data structure. And now tree. Maintaining balance for efficiency and dealing with traversal inefficiency in skewed tree. Skewed tree. Skewed tree is when we go one node and after that go left, then left. This is skewed tree. Left, that is right skewed tree. And if we go all the direction from right, then it is called right skew, and go for left, then it is called left skewed tree. Uh, the next is inability to have cycles limit usage to hierarchical data only, and having a fixed route can restrict data organization. Now the conclusion, what we have studied till now in this PPT. Optimization. First is optimization. Streamlining data structure for fast rendering. In this we can use graph and tree data structure. Integration. Seamless in cooperation with real-time rendering engines. Real-time rendering engines, it is not very useful. Scalability is highly scalable. Adapting to handle complex scans and large data set. We can scan large data set and complex data set, and we can represent also the complex and large data set with the help of tree and a graph data structure. For future developments of tree and graph structure, we must follow these things. The first is in the future advancement of tree and graph structure. We focus on optimization to enhance rendering speed. What optimizing to enhance rendering speed? The second is seamless integration with real-time engines. The first is optimization to enhance rendering speed. The second is seamless integration with real-time engines. And the third is scalable to handle increasing complex scenes and large data sets. So these are the three main things for future developments. This development will play a crucial role in shaping the next generation of computer graphics. If you have any query, then comment that query in the comment box. I will give reply.
This PPT and the document of tree and graph data structure is in the description box, so go and check out that. Thank you.